Another approach to improving the efficiency uses dual frame designs. Those combine all listed working numbers in the country, the white pages of the phone book, with an RDD supplement to cover all of the unlisted numbers, so that you get complete coverage of all working numbers in the country, both listed and unlisted, but you gain considerable efficiency because a large percentage of all working residence numbers are still listed in the white pages. Those dual frame designs then are a way of improving the sampling frame by including knowledge from known lists, the white pages, with the advantages of RDD designs to reach respondents in households with unlisted numbers. When we talked about area probability sampling, we talked about clustering that occurs when you interview multiple households along the same block. Those households are more like each other because they're in the same neighborhood, they have the same kind of cost of housing, and broadly speaking, residents of similar socioeconomic background and occupation and income. Clustering also occurs when, in general, clustering occurs when multiple elements are associated with some single element of the sampling frame. In the case of face-to-face interviews, that would be multiple households on the same block. But in telephone samples, this happens as well. For example, all the members of a household all share the same phone number. In that case, one might select all elements within the cluster for an interview, in which case the probability of each element is the same as that for the selection of the cluster. There are often practical disadvantages in doing that, though, such as an inability to interview all members of the cluster. There's evidence that respondents are more reluctant when there are multiple interviews within the household. What's more, there may be contamination from one respondent to another. And finally, there's within household similarity. Residents of the same household, at least the adult residents, tend to share similar occupation and income, for example, in education. So, alternatively, and most commonly actually, a listing of each member in the household is made, and then one element is selected randomly for interview. This actually leads to an equal probability of selection for each person in the population, which is often a desirable sampling design. The opposite problem of clustering occurs when duplication of elements in the frame occurs. If a household has two working phone numbers, then it has twice the chance of selection into a sample as a household with only one working number. In many surveys, probably most surveys, and some but not all polls, one of the last questions typically asked is, how many phone numbers could I have reached you on? This response is then used to weight the case by the inverse of the number of numbers. So a person with 3 working numbers would have had 3 times the chance of selection into the sample. But by weighting that respondent by 1/3, we restore the equal probability design for each individual in the sample. You can also construct alternative frames for the same sample population. If cost were no object, there would be multiple potential frames that could be used to draw a sample. One might use area probability designs, or landline telephone, or cell plus landline. Likewise, one might use address lists from commercial firms, or from the U.S. Post Office of all mail delivery addresses, or you could construct a detailed listing by interviewers actually walking down selected blocks. Or most commonly for pollsters, a phone call to Survey Sampling International will procure a sample of landline and cell numbers to call. That's the most practical solution. So that wraps it up for talking about sampling populations, target populations, and sampling frames. Next time we'll come back to talk about the selection of elements from within the sampling frame and how that's done.